Okay, so this lesson is on triangles and coordinate proofs. So we're going to be drawing triangles on coordinate planes, like so. First of all, a coordinate proof is a proof that uses figures in the coordinate plane in algebra to prove geometric concepts. To do this, a lot of times you'll have to draw the shape it's describing on a coordinate plane, and these are some guidelines to get the best graph possible. So it says use the origin as a vertex or center of the figure. Place at least one side of the polygon on an axis, and you'll see that we'll do that. Keep the figure within the first quadrant if possible, and use the coordinates that make the computations as simple as possible. So in these example problems, it says position and label each triangle on the coordinate plane, and it describes the shape. And then we drew the coordinate plane here, and then we're just going to draw this shape. So it says isosceles triangle MNP with a base MN that is A units long. So to do this, we're going to draw an isosceles triangle and just center it at the center. So like we'll draw a side here, and then for an isosceles triangle, it'll be the same side length this way. And then the base of our isosceles triangle will be right here. So these are the two legs that are congruent. It says that the base is MN. So we'll say this is M, this is N, and then it's triangle MNP. So this must be point P. Then from here, what it's going to want us to do is to find the coordinates of these points. So this base, it says, is A units long. So this here is A units long, this length. And then if this is A units long and it's centered on the coordinate plane, then this would be 1/2 A, and then this would be 1/2 A units long. And so far, I'm going to zoom in more too. Okay, so with that being said, then N must be at 1/2 A, 0. And then M over here would be at negative 1/2 A, 0. Oh, there it is. Okay. Okay, and then P, it would be 0 for the X because it's just on the Y-axis. And then the height here is B. So if we can't calculate it, then we just choose another variable. Okay, then for number 2, now we're going to do this again, just following the instructions it gives us. Isosceles right triangle PQR with hypotenuse PR and legs B units long. So isosceles right triangle, I'm going to draw a line like this. I'm using the axis to make the 90-degree angle because it's right triangle. And it says it's isosceles, so this would be the same length as this. The hypotenuse is PR, so this would be the hypotenuse, PR. And then the third point would be Q. It says the legs, so these two legs are B units long, so this is B units long, this is B units long. Okay, so now we're going to try to find the coordinates of everything. So Q is at 0, 0, that's easy to find the coordinates of that. Then R right here, this is B units long, so it'd be B, 0. And then this is B units long as well, so this would be 0B. And what they sometimes do, what I've seen on standardized testing, is now they will ask you for the slope of PR. So they'll say, okay, what's the slope of segment PR? Well, slope is y2 minus y1 over x2 minus x1. So using this, we'll label our points. Let's call this x1, y1, and then x2, y2. And then we'll plug the numbers into this. So m equals y2, which is 0, minus b over x2, which is b, minus x1. Okay, so 0 minus b would be negative b. B minus 0 is just b. And then negative b divided by b would just be negative 1. So that's the answer for slope. So the slope of PR is negative 1. So it always throws students off when you're given an image like this and then the slopes look like whole numbers. It's like, well, where'd the variables go? It's because they're canceling in the equation. But that's how you do it. So you just use the variables in the equation and stuff will cancel and it'll come up to a whole number. Okay, then for number 3, it says equilateral TUV, equilateral triangle TUV with sides C units long. So we're going to draw an equilateral triangle. And we'll make this point T, U, B. Okay, so then trying to find the coordinates, it says the sides are C units long and it's equilateral. So all the sides are the same length and they're all C units long. T would be at 0, 0. B, if this is C units long, B would be at C, 0. And then U, if this is C units long and it's isosceles, U would be at the halfway point. So this is half C and then this is half C. So U is at 1/2 C for the X. And then for the Y, I'm going to show you how you could get the Y. Sometimes they'll just choose another variable like D or something, but you can actually calculate that height there. And I'm going to show you how. It's more of like an honors skill, but a lot of you are at more of an honors level. So I will show you how to do it. So to find this height here, we can actually use Pythagorean theorem. So we have a right triangle here if we were to sketch it out. And a squared plus b squared equals c squared. So that's how we're going to do it. So 1/2 c squared plus b squared equals c squared. And we're trying to find b because that's the height that'll be our y coordinate right here. So squaring this, you would apply this to both of these, all of the numbers. So this would be 1 squared is 1, 2 squared is 4, and then c squared is c squared. Plus b squared equals c squared. Subtract 1/4 c squared from both sides. One minus 1/4 is 3/4. So we will get 3/4 c squared. Okay, and then to get b by itself, we have to take the square root of both sides. So then you get b equals square root of 3 over square root of 4 square root of c squared, and you apply the square root to all those numbers. Okay, and then at this point, b equals square root of 3, square root of 4 is just 2, and then square root of c squared is just c. So it's this number. So square root of 3 over 2 c squared. So definitely a higher level problem. You won't see any of those on the homework, but just so you're aware. This is definitely bridging into like pre-calculus and that kind of thing. So congrats on being smart. Okay. Next, 4 over here. It says right triangle ABC with one leg twice as long as the other. So right triangle ABC. So I'm going to use the two axes to make that right angle. So here's right triangle. A, B, C. It says one leg is twice as long as the other. So if this is A units long, then this would be 2A units long. Okay, then to find the coordinates of everything, let's see, C would be at 2A, 0. A would be at 0, 0. And then B would just be at 0A. And again, if it asks for the slope of BC, just x1, y1, x2, y2, you would do y2 minus y1 over x2 minus x1. Get negative a over 2a minus 0 is 2a. The a's cancel and you get negative 1/2. So the slope of BC is negative 1/2. Okay, then cross these two out, and then we're moving to the back. Okay, the first examples are just like the ones we just did, so you can cross those out. And then we're jumping down to number 5. These are very similar to what you'll see on the homework. It says, name the missing coordinate of each triangle. So now that we've built the concepts, this gets a lot easier. So it has an isosceles triangle here. That means that this point is at the midpoint of this line here. So half of this length is 2p, so half of that would be at p. So this question mark is just p. So C is at p, and then it has the q there for us. Okay, and then for number 6, it shows its isosceles, shows this length is 2a, because this is at 2a, so this would be 2a. And then t would be at, x coordinate would be 2a, and then the height is 2a as well. Okay, and then number 7, again, it shows its isosceles. And this is at 2g, so this is 2g. This is also a length of 2g. So therefore E would be at negative 2g, 0. And then it just wants the x coordinate here, where that would be at 0. So F is at 0b. And then number 8, let's call this isosceles. I know it's probably not, but just call it isosceles. It's saying that this length is 3b, so then this length would be 3b, and then M would be at 0, 3b, like that. Okay, and then the last exercise down here, we're not going to go through all the nitty-gritty with the work, but I will explain how this works. So it says the segments joining the midpoint to the sides of a right triangle form a right triangle. So it's saying that this is a right triangle. Points R, P, and Q hit at the midpoint of each of those segments. Prove that RPQ, this little one, is a right triangle. Okay, well, we would first find location of R, P, and Q using midpoint formula. So for example, for R, to find midpoint, it's x1 plus x2 divided by 2, y1 plus y2 divided by 2. That gives you midpoint. So it would be the x's, add the x's, 0 plus 0, divided by 2, add the y's, 2b plus 0, divided by 2. And you would get 0. 2b over 2 is just b, so 0b. That would be r. So you could do that for each one of these. Then find slope of RP and PQ to prove perpendicular. So using the method we saw in some of the other problems, you could find the slope of this and the slope of this. And if those slopes are negative reciprocals, then it's perpendicular. So negative reciprocal slopes. This is definitely a higher level concept. And then for 3, once you prove that these lines are perpendicular, if they're perpendicular, then you have a right angle, then you have a right triangle, and you could prove that that's a right triangle. Wouldn't that be so fun? Okay. Anyways, that's just all. The homework won't be like this, but I wanted to show you like what the next level is. So for your homework, you have homework 5-6 on Schoology. If you need any help, let me know. And yeah, and then work on Alex.